So, in our circle theorem, the next thing we'll look at is angles in a segment. Angles in a segment. In a particular segment, we have several angles inside. First of all, can we stop writing for a moment? Let's look at what a segment is. We say a segment is the what? Area bounded by a chord or an arc of a circle. So here we have an arc of a circle of this nature, or this is an arc. The area that is bounded here is what? A segment. This area bounded here. Can you see this triangle here? Or this triangle inside here? Or this other triangle? Each of these is called what? A segment. Like the word segment means a portion of a circle. So there are some angles that are found inside a segment, and there are theorems that support such angles. And the next theorem we'll look at is theorem 16. Theorem 16 says that what? The angle subtended by an arc of a circle at the center is what? Twice the angle subtended at any point of the circumference. So if we have a circle of this nature, we are saying that the angle here, AOB, which is at what? The center. This angle is found here at the center. The center here is what? AOB. At the center of this circle, the angle that is found there is twice the angle found at any other point of the segment. So this is another angle in the segment here. So we are saying that AOB is what? 2 times what? AXB. We can also have the diagram of this nature. Here is same thing as saying AOB is what? 2 times AXB. Very clear to understand. The next theorem we'll look at is theorem 17. Theorem 17. Theorem 17 says that the angle in a semicircle is a what? Right angle. Now, it gives us thoughts. Why should the angle found in a semicircle be a right angle? Recall from theorem 16, we said that what? The angle subtended at the center of a circle is what? Twice that subtended at what? Any other point of the segment. So what is the angle subtended at the center of this circle? In this, remember this is a semicircle, right? What's the angle subtended here? What's the value of AOB? AOB is what? 180. 180 angle that is found what? On a straight line, which is 180 degrees. And we can recall from theorem 16, the previous theorem, that what? AOB is equal to what? 2 times AXB. That means that AXB is what? AOB divided by what? 2. So if this angle is 180 degrees, then we can say very clearly that what? The angle AXB is what? 180 divided by what? 2. That's 90 degrees. So that proves this theory very vividly. We say that what? The angle in the semicircle is what? A right angle. Let's take a few examples to illustrate what we have done so far. Theorem 16 and 17. The first question here says, in the diagram below, which is this diagram, so as we are analyzing the question, you can make reference to the diagram and confirm the information. The diagram below, O is what? The center of the circle. And so this is O, which is what? The center, is the center point. And they're telling us that BOC is what? Diameter. Pay attention very closely. Okay, because we're going to dissect. BOC is what? The diameter. So if BOC is the diameter, it means the angle here is what? 180 degrees. And from theorem 17, we said that the what? The angle in a semicircle is what? A right angle. So this is a semicircle. So this angle here is what? A right angle. So this must be what? 90 degrees. So they're saying BOC is what? A diameter. And angle ADC is 37 degrees. Where's ADC? ADC. 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 Angle ADC is 37. So this angle is what? 37 degrees. Okay, what I will ask to find, calculate the angle what? ACB. ACB. Meaning we're asked to find this angle here. Alright, so let's take the diagram out. Let's bring the diagram out in a very clear manner so that we can better analyze this question. Are we done with this part of the board? Okay. We can draw the diagram in a more clear manner. And we said that what A, we have A, B, O here, and what C. So this is what? A semicircle, this is the diameter. So we said just now that this angle is what? 90 degrees. And we have A, D, C, which is 37 what? Degrees. For us to find this angle. Okay. Has to find this angle. Now, recall from the previous theorem, which is theorem 15, that this angle, we can recall from theorem 15 that angle ABC is what? Equal to what? Angle what? ABC. That is, this angle is equal to what? This angle, because they are found on the same chord. So this angle is what? 37 degrees. So this angle is 37 degrees and this is 90 degrees. We're asked to find what? Angle what? ACB. So therefore means sum of angles, recall, sum of angles in a triangle is equal to what? 180 degrees. So it therefore means that, therefore, angle, the first angle we're taking here, which is what? Angle ABC plus the angle BAC plus the angle ACB is equal to what? 180 degrees. So we can therefore say that 37 degrees plus 90 degrees plus what? ACB is equal to what? 180 degrees. So angle ACB is equal to what? 180 minus the sum of these two angles, which is 37 plus 90. What would that give us? 127 degrees. So by the time we remove 127 from 180, we have the value of what? Angle ACB. And what would that be? That's 53 degrees. So this angle is what? 53 degrees. Okay. So let's go to example 2. Example 4 rather, the next example. Example 4. Calculate x in the diagram below. Calculate the value of x in the diagram below. Calculate the value of x in the diagram below. This is the nature of the diagram. This is x degrees, the angles we are looking for, and this is P, O, R. This is 114 degrees. So this question is saying calculate the value of x in the diagram below. This is the nature of the diagram. Can we pay attention for a moment? In this particular diagram, it will interest us to know that here, the opposite angle to this, now there are two angles around POR, if you observe. The first angle here is 144 degrees, and the opposite angle to this angle, or rather the corresponding angle that will work with this angle, is going to be here. But now the diagram is drawn the other way around, so we need to find this angle here, POR. So therefore, POR is equal to what? 360, because sum of angles at a what? Sum of angles at the point is 360. So 360 minus 114 degrees. What would that give us? 360 minus 114. 216 degrees. So therefore this angle is what? 216 degrees. If this angle is 216 degrees. From the previous theorem, we said that what? The angle subtended at the center of the what? Circle is what? Twice the angle that is found at any point on the segment. So it therefore means that, therefore, angle POR is equal to what? 2 times what? X. Because we're looking for X. What is angle POR? 216. So 216 degrees is equal to what? 2x. Therefore, x is equal to what? 216 degrees.
But that means 246, not 216. It's 246.
So 246 divided by what? 2. So what would that give us? Half of 246. So 2 goes into 2 once. Okay, 2 goes into 4 2 times, and 2 goes into 6 what? 3 times. That's 123 degrees as the answer. So let's quickly take what we have on the board as we move over to the next theorem.